All right, guys, so the whole goal of today is to talk to you guys about section 3.5, which is about overlapping triangles. So if we take a look at A, what we're trying to do is come up with some triangles that are overlapping. A lot of times you guys look at pictures like this and you immediately want to pick out these triangles because you see those vertical angles and you're like, oh, I know those angles are congruent, so let's try and get those triangles congruent to each other. Oftentimes we're using the triangles that are overlapping. So let's take a look at these triangles that we see. So if you notice, we have this pink triangle right here, and the pink triangle is overlapping with this blue triangle. They share a reflexive angle right here, and oftentimes we use that reflexive angle. Okay, and now let's see if I can cut this and move it. Yay! So there is one pair of overlapping triangles. Another pair, hopefully that you see, are these kind of bigger triangles towards the bottom. So we also have this big red triangle, like a Christmas on you, and this green triangle right here. So that's another pair of overlapping triangles. Again, we may be using these. We don't know. Look at, they fit right in there. So we don't know which triangles we're going to be using. So again, as you go through your proof, and this is why it's important that you're using paper and pencil, as you go through your proof, sometimes you're going to start with the pink and the blue and you're like, oh, I just can't get those congruent. So you might have to jump to the red and the green. And again, there's a reflexive side down there. So you already have a side there. There's a reflexive angle with the pink and the blue. So you already have an angle there. Or maybe it is this triangle 1 and this triangle 2 and you have to use these vertical angles. So as you go through these, please make sure you're looking for the overlapping triangles. In B, right away you guys see these 3 triangles, right? So it's like, oh, look, we have 3 triangles. You also have some overlapping triangles. So there's my blue one, and here's my pink one. Okay, you guys can see that little section is kind of overlapping right there. And again, I recommend you guys pulling these triangles out, keeping the vertice names so that you don't lose it. Be careful when you're naming your angles. For example, if this is a B down here, you cannot call this angle B because there are actually 2 angle Bs. There's one in triangle 1 and one in triangle 2. So you have to name the angle using, you know, three letters. But I recommend you guys redrawing the picture with them pulled apart if those are the triangles you have to choose. And then C looks very similar to the first one. Again, you guys try to jump in right here like, oh, I have these triangles and they have vertical angles congruent, and which is absolutely true. But you also have this triangle up here and this triangle right here. And what is so special about these triangles is that you have a reflexive side. So it's like, well, that's really nice. You might be able to use that reflexive side, right? I knew I had one side on this. Let me read it. So we have those triangles right there, right? We also have these bigger triangles towards the bottom. So keep in mind, again, these still have a reflexive side. So as you pull these apart, you can use that reflexive side. Okay, so that's kind of the gist of overlapping triangles. I'm going to do one proof with you guys. And then we'll finish proof number 2 and 3 in class on Friday. So here we go. Let's give the information. So they're telling me that DB is congruent to AC. I'm going to write that down. I'm also going to kind of highlight that information and what that means for me. I see that DB is a segment in a triangle and AC is a segment in a triangle. So I'm thinking I'm probably going to be using those triangles. Another piece of information is that AB is congruent to BC. Okay, so we have this piece of information. And let's go ahead and put that down. AD is congruent to BC. And those are both given pieces of information to me. So I'm thinking to myself, why would I pull this triangle out? I wouldn't, because I don't know how big this side is and I don't know how big this side is. So I'm not using that little triangle. I'm thinking I'm going to pull out this big triangle. So again, if you'd like to pull it over to the side, you absolutely can. So I'm going to draw mine a little bit smaller over to the side. And we're going to name that ACB. Okay, ACB. And then my second triangle is over here. And I'm naming it DAB. Notice nothing is drawn to scale. They told me that DA is congruent to BC. They told me that DB is congruent to AC. So I either need to get my included angle, angle D congruent to angle C, or that third side, which is AB congruent to AB. Wait a minute. AB congruent to AB, since they're overlapping triangles, I'm always looking for that reflexive angle or that reflexive side, and I found it. So AB is congruent to AB because any segment is congruent to itself. So then I have triangle ADB congruent to triangle BCA because of side, 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 step 1, 2, and 3. Once the triangles are congruent, I now can say their pieces are congruent. Right here, I'm going to pull it out. Angle D is congruent to angle C. And my reason is, if triangles are congruent, then their parts are congruent. Okay, so again, you can use overlapping triangles with the reflexive property. Auxiliary lines are still a thing. So lots of things you guys can start using to figure out these proofs.